Okay, so we've got a video on a revision for the test coming up, and I've got 13 minutes before the bell goes, so I'm hoping I'll get through this. Okay, so the first one's a straightforwards, so have a go, and when you're ready, come back live. Okay, so the first one, I'll change the pen. Okay, first one we're subtracting, but we're subtracting uphill, so -2 minus 3 equals -5. 3 minus -1 is plus, so the first answer is just -5 plus 4i. Next one, we've got -6 plus 3, so -6 plus 3 is -3, and then 3 3s are 9, plus 2 is 11, so we've got 11i. This is the modulus, so the modulus will be the square root of 10. Z1 over Z2 I'll have to do properly, so -2 plus 3i over 3 minus I, then multiply by the conjugate, 3 plus I over 3 plus I. So the denominator will be 10. So -6 minus 3 is -9, -2 plus 9 is +7, so it should be -9 plus 7i over 10. Okay, this one here is the inverse of z, and so we just take the conjugate, which is 3 plus I, and divide by the a squared plus b squared, which will be 10. Okay, z squared, so we've got -2 plus 3i squared, so I've got 4 minus 3 2s are 6, 2s are 12, plus 9i squared, and then that becomes -9. So I should get that, -5 minus 12i, and this just means the conjugate, which is straightforward, so the conjugate will be -2 minus 3i. You just change the sign in between. Okay, moving on. Okay, so next one, find the value of and convert root 3 minus I into polar form. Okay, so go. Okay, you're back. So we get 15i to the 5, which is 15i to the 4 times I, and I4 is I squared, which is -1 squared, which is a plus, so 15 times +1 is 15, so the answer is just 15i. Okay, next one, into polar form, so the modulus equals the square root, equals the square, beg your pardon, equals root 3 squared plus -1 squared, which is, oh no, it is the square root, sorry. So the square root of 4, which is 2, so the modulus, the length is 2. Okay, argument, tan -1 of -1 on root 3. So all stations to central, so I've got to be in that quadrant there, I think. Just think, hang on, let's make sure I'm right. So root 3 minus I, so root 3 minus I, so I'm actually in the 4th quadrant. Okay, so root 3 is the real part, minus I is the complex part, so I'm actually in the 4th quadrant, I'm not in the 2nd quadrant. Okay, so tan minus, so argument is tan minus 1 on root 3. 1 on root 3 is the same as pi on 6, and so to get in the 4th quadrant will be minus pi on 6. So to convert into polar form, the answer would be 2 cis minus pi on 6. So the trick is you've got to sketch it so you know what quadrant, because it could have been in the 2nd quadrant, but it wasn't. It was in the 4th quadrant, and the 4th quadrant is the same as the -1st quadrant, because our arguments must be between theta minus pi and positive pi. Okay, let's move on. Okay, just some little equations, so bang them out, hopefully you get them right. Okay, so the first one is we're just going to move that across, so z will be 2 minus 3i. To move that across, we divide, and then we multiply by the conjugate. So we get 15 plus 2i squared, which will become -2, so that's 13. And then we've got -5 minus 6 is -11i over 10. Okay, next one, we've got to move that across first and then divide. So Z would be 7 plus 9i divided by 2 plus I, and then multiplied by the conjugate. So the denominator will be 5. And then we've got 14 minus 9i squared, so 9 minus 9i squared is plus 9, so 14 plus 9 is 23. And then we've got minus 7 plus 18 is plus 11. Okay, moving on. Okay, page, finding this, I'm going to do modulus form. So modulus equals, so I've got to turn into 2 plus I. So that's going to be root 5, and the argument is tan. Oh, this is not pretty. I haven't got a pretty answer here. Sorry, guys. So tan minus 1.5. You've got to use in radian mode. So I've got a calculator that I'm not used to. So what I'll do is, like, once you've got that, then the square root would be square root of 5, and then you've got to convert that into radians, whatever it is. Like, I just haven't got a calculator that's got the right answer there, and then you go cis whatever that number is, and you have a half of it. Okay, and then you can convert that into decimals from there. Okay, so I'm sorry I haven't got an answer for that one. I've only got 4 minutes before the bell goes. But basically, this is in radian mode. You'll get a decimal answer here, and then you halve it, and you can convert that, like, square root of 5, and finish it off from there. So actually, beg your pardon, that modulus should be just, no, modulus is square root 5, that's right. And then you halve that number. Then you take it out to the power of a half. Okay, moving on. Okay, we've got 2 pages to go. So we've got a quadratic, we've got an equation, so you can use the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac divided by 2a. So minus 2 plus or minus minus 16 over 2. So it's minus 2 plus or minus 4i over 2. So the answers are minus 1 plus or minus 2i. So that's your answer. And if you want to, you can write it out. Minus 1 plus 2i, minus 1 minus 2i. Okay, moving on. Okay, so we're going to factorize. So I'll complete the square, might be just as easy. So we got x squared minus 4x. To complete the square, we halve and square, so we get plus 4. And then we've got plus 3 to get up to our 7. So equals x minus 2 squared minus 3i squared. So it's x minus 2 minus root 3i, x minus 2 plus root 3i, and that's it. We're factorized. Don't forget, you've got to square root the 3. And one more page, I think. See what happens on the next page. Okay, so z equals, draw on the eigenplane. So just some practice on eigenplanes. Okay, when you're ready to go, then come back. Okay, so we've got 1, 2, minus 1, minus 2. You'll have grid paper in the test situation. So that's the imaginary, and that's the real. So root 2 is about 1.4. So that's Z1. 2, I've got to have some negative numbers. So 2 minus 2i is down there somewhere. So that's Z2. And then let's see what Z1, Z2 looks like. So Z1 times Z2 equals 2 root 2. So that's real parts. We've got minus 2i squared, which will be plus 2. So we've got 2 plus 2 root 2 is the real part. And then the complex part would be 2 minus 2 root 2i. So 2 plus 2 root 2i, 2 plus 2 root 2. Okay, so root 2 is 1.4, 2.8, 4.8. So we're over here somewhere. So 3, 4, 5. So 4.48. And then that's 1.4 times 2 is 2.8. 2 minus 2.8 is minus. So we're down somewhere down here. So just work out a decimal equivalent, and that would be about Z1 times Z2. Okay, that's a cross-section of what you could be expected to do. Thanks, bye.